Hello there, you're welcome to my YouTube channel. We have a beautiful exponential equation which we have to solve together. What I have here is 8 raised to power x minus 2 raised to power x all divided by 4 raised to power x minus 2 raised to power x, and all is equal to 17. Now for us to solve this question, I'm going to make or express 8 and 4 as a power of 2. The reason why I'm choosing to use the power of 2 is because of this 2 I have here and here as well. So let's do that. 8 will be expressed as 2 raised to the power of 3, because 2 raised to the power of 3 is 2 times 2 times 2, which is what? 8. Okay. Now, what I have, remember, I still have an exponent of x. So let's put it here like this. Okay. And then minus 2 raised to the power of x, then all divided by what? What about 4 now? I'm going to express 4 as a power of 2. And that will be what? 2 raised to the power of 2. Then with the exponent of x minus 2 raised to the power of x. All of this is equal to 17. Now, from one of the laws of indices, for every a raised to the power of b, and then with x like so, you can interchange the exponent. Of course, b and x here are commutative, so you can switch position. Now, I can rewrite this as a raised to the power of x, then times what? The exponent of b, like I've written. So the reason why I'm doing that is because I want to have 2 raised to the power of x expressed here as a whole, so that I can now take it up from there. Now let's continue. So I'm going to express 2 raised to the power of 3, then raised to the power of x like this. 2 raised to the power of x. Remember, they're the same thing since the exponents here are commutative. We can switch the position. Then minus 2 raised to the power of x, all divided by what? The same thing here. 2 raised to the power of x, then 2 here, minus 2 raised to the power of x, all is equal to 17. But I want you to look at this right here and tell me what is common. 2 raised to the power of x is common. Here too, 2 raised to the power of x is common. Okay, so I'm going to factor 2 raised to the power of x out. For example, let's say you have y raised to the power of 3 minus y. Of course, you can factor out y. You have what? Y squared minus what? 1. That's exactly what I'm going to do right here. So let's factor out 2 raised to the power of x here and here as well, since they are common when you compare the two terms. So I'm going to have 2 raised to the power of x, open a bracket, 2 raised to the power of x squared minus 1. I hope you know why I'm having squared here, because if you bring out 2 raised to the power of x from this, or let me just show you what I did. If you have 2 raised to the power of x all raised to the power of 3 divided by 2 raised to the power of x. Now notice something. 2 raised to the power of x, we divide this, you have what? 2 raised to the power of x squared. It's like saying y cubed over y. Y goes into y cubed, you have what? Y squared. That's exactly what I did here. Now all divided by what? The same thing I'll do here. Factor out 2 raised to the power of x, then bracket 2 raised to the power of x minus 1 again. All right. All of this is equal to 17. 2 raised to the power of x cancels 2 raised to the power of x. What do I have left? I have this and I have this. Is something coming to your mind now? Yes. Difference of 2 squares. Difference of 2 squares. I can put a square here and it doesn't change 1, because 1 raised to the power of 2 is also 1. Now, using difference of 2 squared, if you have a squared minus b squared and you want to factorize this, you have open 2 brackets and write a plus b in one of the brackets and then a minus b in the other bracket. That's what I'll do here in a difference of 2 squares. So I'm going to have what? 2 raised to the power of x plus 1, and then what? 2 raised to the power of x minus 1, all divided by what? 2 raised to the power of x minus 1. And this is equal to 17. Can you see what's happening here? Can you see what is happening? Can you see this? This and this are similar, so they cancel out. And what do I have left? I have 2 raised to the power of x plus 1 is equal to 17. So I'm going to subtract 1 from both sides. Subtract 1 here, subtract 1 here to get rid of 1 from here. I now have 2 raised to the power of x is equal to, what is 17 minus 1? That is 16. Okay, so I'm going to express 16 as a power of 2 again. so that it will match with the base that I have here. Now 2 raised to the power x is equal to 2 raised to the power what? 4, because 2 raised to the power 4 is not 8, is 16. 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. All right, now that they have a common base, I am going to equate the exponent. So which means x is equal to 4. And this is the only value of x that will satisfy the equation. I hope you enjoyed this video. Kindly like, share, and subscribe to this channel for more content like this. I hope to see you in the next one. It's bye for now.